Hi everyone, welcome back to the channel. In today's video, we are going to learn and understand how to reduce the percentage heat loss due to moisture present in air in a boiler system. We will cover the following key topics in this session. The first topic is why heat loss occurs in a boiler. Next, the second topic is what is the percentage heat loss due to moisture present in air in a boiler. Next, the third topic is ranges of the percentage heat loss due to moisture present in air in a boiler. Next, the fourth topic is how to reduce the percentage heat loss due to moisture present in air in a boiler. We will cover the above topics in the upcoming slides. Next, we will learn and understand the why heat loss occurs in a boiler. When a boiler burns fuel to produce heat, not all of that energy is used efficiently. Some portion of it is always lost. A boiler burns fuel to generate heat, which is then used to produce steam or hot water. However, not all of the heat released from the fuel is transferred to the water. Some of the heat is inevitably lost for various reasons. Please refer to the picture below for a better understanding. Next, we will learn and understand what is the percentage heat loss due to moisture presence in combustion air in a boiler. When combustion air, ambient air, is drawn into a boiler, it contains moisture in the form of water vapor. The amount of this moisture depends on the ambient humidity and temperature. Vapor in the form of humidity in the incoming air is superheated as it passes through the boiler. Since this heat passes up the stack, it must be included as a boiler loss. During the combustion process, this moisture is the first step. The moisture is heated from ambient temperature to 100 degrees Celsius. It is called sensible heat. The next step, evaporated, it is called the latent heat of vaporization. The final step is superheated from 100 degrees Celsius to flue gas exit temperature. It is called superheat. This entire process consumes heat energy, which is not used for steam generation and is instead lost in the exhaust. Next, we will learn and understand the ranges of the percentage heat loss due to moisture present in air in a boiler. In industrial coal, oil, gas fuels, its percentage of the heat losses ranges from 0.2% to 1.2%. Next, in biomass fuels, its percentage of the heat losses ranges from 0.8% to 1.5%. Even small percentages can cause significant energy loss over time. Next, we will learn and understand how to reduce the percentage heat loss due to moisture present in air in a boiler. Below are the recommended strategies to reduce the percentage heat loss due to moisture present in air in the boiler. Let's now look at practical strategies to minimize this type of heat loss. The first recommendation, to reduce the heat loss, to use the preheated combustion air. Recover waste heat from flue gas or boiler exhaust. To improve the air quality, consider following control measures. Preheating combustion air using air preheaters or economizers lowers its relative humidity, which in turn reduces the energy required to evaporate moisture. The second recommendation, to reduce the heat loss, to intake air from dry locations and use the dryer. Moisture in ambient air contributes to latent heat losses. Drawing low humidity air into the boiler minimizes this effect. To improve the air quality, consider following control measures. Draw intake air from a dry, enclosed area, not directly from humid outdoor air. Use air dehumidifiers in extreme cases. It is applicable in precision systems or high-efficiency boiler. Let's now look at practical strategies to minimize this type of heat loss. The third recommendation, to reduce the heat loss, to avoid wet air sources. High humidity environments, coastal areas, monsoons, can significantly increase air moisture content and related losses. To improve the air quality, consider following control measures. Draw combustion air from controlled indoor environments with lower humidity. Avoid air intake from cooling tower areas, wet basements, or other humid zones. The fourth recommendation, to reduce the heat loss, to minimize excess air. The excess combustion air introduces more moisture into the system, increasing heat losses. Optimizing air input reduces this. To improve the air quality, consider following control measures. Use oxygen sensors or flue gas analyzers to fine-tune air-to-fuel ratio. Next, to maintain excess air within recommended ranges. Let's now look at practical strategies to minimize this type of heat loss. The fifth recommendation, to reduce the heat loss, to use oxygen trim systems. These systems continuously monitor and adjust the fuel-air ratio for optimum combustion, helping to reduce both dry flue gas and latent heat losses. To improve the air quality, consider following control measures. Maintains minimal excess air and therefore minimizes moisture-related losses. Next, we summarize, and conclusion of this video is. Let's quickly recap what we learned. Heat loss due to moisture in combustion air occurs in three stages: sensible, latent, and superheat. And it can range from 0.2% to 1.5% depending on fuel and air conditions. Effective strategies include using preheated air, drawing air from dry sources, and optimizing air supply. By applying these practices, we can significantly improve boiler efficiency and reduce energy.
We hope everyone learns and understands the percentage heat loss due to moisture present in air in the boiler. If you found this video helpful, don't forget to like, subscribe, and share with your colleagues. Thanks for watching, and we'll see you in the next video. Hit the bell icon to stay updated with more boiler and power plant tutorials.